Welcome you all. Today we are going to discuss one more exercise in a turbocharging. This exercise is from the textbook Introduction to Internal Combustion Engine, Richard Stone. The question is, a turbocharged diesel engine has a compressor operating point that is marked by the cross on the accompanying figure. If the compressor entry conditions are a pressure of 1 bar and a temperature of 20 degrees centigrade, determine the volume flow rate of the compressor and the power absorbed by the compressor. Assuming the following properties for air, gamma is equal to 1.4, Cp is equal to 1.01 kJ per kg Kelvin. The fueling rate to the engine is increased and the air mass flow rate into the engine is increased by 50% and the volume flow rate out of the compressor increases by 22%. State any assumptions made. Establish approximately the new operating point for the compressor, its rotor speed and the power that is absorbing. The given compressor, the performance characteristics is given and is marked by a line. The method is a turbocharged diesel engine. The compressor inlet pressure is 1 bar. The inlet temperature is equal to 20 degrees centigrade, that is equal to 293 Kelvin. Then gamma of air is equal to 1.4, Cp of air is equal to 1.01 kilojoule per kg Kelvin. Determine the volume flow rate out of the compressor and the power absorbed by the compressor. If the fueling rate is increased and the air mass flow rate into the engine is increased by 50% and the volume flow rate of the compressor increased by 82%. State any assumptions. Establish approximately the new operating point of the compressor, its rotor speed and the power absorbed. Solution. The compressor performance characteristics is given where in the x-axis mass flow parameter, that is m into root T by P, where in the y-axis pressure ratio it is in bar, and here the compressor speed parameter they given where the n is in rpm and T is in Kelvin. Then the compressor isentropic efficiency is in percentage, that is fraction. From the figure, with this operating point, we observed that the pressure ratio is equal to 1.62, then P2 is equal to P1 multiplied by 1.62, that is equal to 1 multiplied 1.62 equal to 1.62 bar. Then mass flow parameter is equal to 4 into 10 to the power minus 5. This mass flow parameter is equal to m into root T by P is equal to 4 into 10 to the power minus 5. And the isentropic efficiency of the compressor is equal to 0.66. We know that the isentropic relation in the compressor T2 by T1 is equal to P2 by P1 whole to the power gamma minus 1 by gamma. Then T2 is equal to T1 multiplied by P2 by P1 whole to the power gamma minus 1 by gamma. Assume it is equation 1. Then T2 is equal to 293 1.62 whole to the power 0.4 divided by 1.4, we will get 336.301 Kelvin. And we know that the isentropic efficiency of the compressor is equal to ideal compression over actual compression. That is, isentropic efficiency of the compression is equal to T2 minus T1 over T2 dash minus T1. That is, T2 dash is equal to T1 plus T2 minus T1 divided by isentropic efficiency of the compressor. This is equation 2. Now this T2 dash is equal to T1 293 plus 336.301 minus 293 over 0.66. We get T2 dash is equal to 358.60 Kelvin. Now this mass flow parameter m into root of T by P is equal to 4 into 10 to the power minus 5. Then mass flow rate is equal to P divided by root T into 4 into 10 to the power minus 5. That is equal to 1 into 10 to the power 5 over root of 293 into 4 into 10 to the power minus 5. We get mass flow rate is equal 0.234 kg per second. We know that ideal gas relations, that is P2 V2 is equal to m into R into T2 dash. So V2 is equal to MR T2 dash over P2. That is equal to mass flow rate we added, that is 0.234 kg per second. R for air 0.287. Then T2 dash is equal to 358.60 over P2 1.62 into 10 to the power 2. So V2 is equal to 0.14845 meter cube per second, that is equal to 148.45 liter per second. Answer 1A. Then the second question of the one is power output. Work of compressor is equal to mass of air into Cp of air multiplied by T2 dash minus T1, that is equal to 0.234 into 1.01. Then T2 dash 358.6 minus 293, we get 15.50 kilowatt. Answer 1B. Now mass flow rate is increased by 50%. Therefore, mass is equal to 100% plus 50% multiplied by 0.234. We get 1.5 multiplied by 0.234. That is equal to 0.351 kg per second. Then the volume flow rate is increased by 22%, means that is volume of air, that is equal to 1.22 multiplied by 0.14845, that is equal to 0.1811 meter cube per second. Now from the ideal relation, P2 V2 is equal to MR T2 dash. Then T2 dash is equal to P2 V2 by MR, that is equal to P2 unknown value, V2 we know that 0.1811, then mass flow rate 0.351, then R 0.287, we get T2 dash is equal to P2 multiplied by 179.78, assume it is equation 3. Now for getting new operating point, we don't know pressure ratio. Therefore, assume the pressure ratio from some lower value to upper value. So already we derived the pressure ratio is equal to 1.6. Here mass flow rate of air increased, the volume flow rate is increased, so that the pressure ratio is expected to increase. So assume that this pressure ratio is increased from 2. Initially assume this pressure ratio is equal to 2, and then from the figure efficiency of the compressor is 0.66. Then from the equation 1, P2 is equal to P1 multiplied by P2 by P1 whole to the power gamma minus 1 by gamma. Then we get 357.7 Kelvin. Then thus P2 minus P1 divided by efficiency of the compression, we get the P2 dash is equal to 390.2. Then from the equation 3, we observed that P2 dash is equal to P2 multiplied by 179.78. So we get from this equation 359.56 Kelvin. Now the pressure ratio increased 2.1, 2.2, 2.4 and 2.5. Now we can find all other parameters. This T2 dash for the equation 2 and T2 dash from equation 3. Now when you are plotting a graph showing in x-axis P2 by P1 and y-axis T2 dash, assume that x-axis 1 unit is equal to 0.05 and the y-axis equal to 10 Kelvin. Outlet temperature of the compressor T2 dash by equation 2 is given in this line, and the delivery temperature T2 dash by equation is given in this line. So these two are intersect at this point where P2 by P1 is equal to 2.26 and the T2 dash is equal to 406 Kelvin. Now the isentropic efficiency of the compressor at a pressure of 2.26, it is between the 0.60 and 0.63, assuming efficiency of the compressor in this condition equal to 0.62, and the speed parameter n by root of t is between 4103 to 4690. So this rotor speed parameter is equal to 4103 plus 0.62 multiplied by 4690 minus 4103. We get 4466.94. That is approximately, assume this rotational parameter is equal to 4467. N by root of t is equal to 4467. N is equal to 4467 over t2 dash. That is equal to 4467 root of 406. We get speed of the compressor is equal to 90,006 RPM. Answer 2A. Then second, the power absorbed is equal to mass of air into Cp of air T2 dash minus T1. That is equal to mass of air 0.351. Cp of air 1.01 multiplied by 406 minus 293 is equal to 40.06 kilowatt. Answer 2B. Now assumption in this question is temperature can be found from the compression, that is T2, T2 dash by isentropic and actual compression relation. Also the temperature can be found from the PV is equal to MRT, ideal gas equations, and the operating points are obtained from this temperature and the pressure ratio relations. Thank you.
Subscribe to our channel, like if you're satisfied, and share because it may be useful to someone.